Hello, we are Gagyong Kim and Yurim Chu. Our topic is Educational Fairy Tale Reimagination and Block Coding with Generative AI Ding Dong. We will go over our service planning, development, and testing. First, let's start with the service planning. During COVID-19, students became socially isolated due to online classes. This prolonged isolation slowed their development of creativity and problem-solving skills. Research shows digital puzzles and interactive storytelling can improve these skills, so we decided to combine these two approaches in our solution. This led us to develop Ding Dong that consists of an interactive storytelling chatbot and block coding, a form of digital puzzles. While there are similar services, Ding Dong has 4 key differences that make it distinctly different from other services. Now, let's move on to development, but first, we will show them a video.
Ding Dong can start by selecting any assignment given to them. The first step is to recreate a story using a chatbot. Once the initial question is asked, the chatting continues for at least 5 exchanges before concluding. After the conversation, a new story is generated based on the chat history. And Ding Dong can proceed to the next step. In the next step, students can create images of story characters. By selecting hairstyle, hair color, and expression options, characters and backgrounds are generated to match the selections. With the created characters and backgrounds, Ding Dong can start block coding right away. Using the provided blocks, they can animate the story according to the adapted storyline. If additional characters are needed, Ding Dong can add them directly. They can even sketch directly on the images to create custom shapes. The block coding project can be saved for future use, and Ding Dong can review it by running the code.
As you saw in the demo, Ding Dong has 3 main features: reimagine fairy tales with chatbot, generate characters and backgrounds, and create animations with block coding. Let me start with the first feature, chatbot, focusing on the challenges we face during development. A key challenge was ensuring the chatbot reflects updates whenever the teacher unloads a task. LLMs struggle with this, and repeated fine-tuning can reduce performance. That's why we chose RAG, which Microsoft research shows produces richer results. With RAG, the chatbot now creates new fairy tales using data from our database. We also needed to design effective prompts since responses were inconsistent without optimization, sometimes following exact endings or using different output formats. After testing over 200 prompts, we found one that works best. Now, the chatbot consistently generates rich stories with onomatopoeia, dialogue, and appropriate endings in JSON format. Lastly, we ensured stable answers even if the HTTP connection is interrupted by building the API with Fast API and gRPC for reliable performance.
So let's move on to our second feature, image generation. We faced 3 key challenges: choosing the right model, maintaining consistent visual quality, and reducing the generation time. First, we tested 3 image generation approaches. The first 2 options, Controllet and LoRa, showed distorted outputs and prompt limitation. So, we chose Midjourney for its better prompt handling and processing. Next, for consistent visual quality, we developed predefined prompts. We crawled and classified elementary book characters and created matching Midjourney prompts and stored them in our database for use with story summaries. Here is before and after using predefined prompts. Random keywords gave inconsistent result, but predefined prompts produced high-quality images with accurate features like hair and expressions. Our third challenge was reducing generation time. Instead of individual pose generation, we used a single sprite sheet prompt for multiple poses. This improved approach cut generation time by 20%. Let's check our streamlined image generation process. We first create reference images through the imagine and upscale process, then generate others based on the same style. Here is a sequence diagram for image generation. The image server sends imagine request to proxy, triggering Midjourney both through Discord API. And proxy updates queue status while image server monitors progress. And monitoring ends upon the task completion. And our final feature is block coding for generating animation. And let's explore how we save and manage result, align terminology with curriculum, and guide the block selection. First, for saving and managing result, we integrated Firebase with our open source based block coding interface, enabling save and load functionality. Second, we aligned block terms with curriculum by simplifying names and adding description. And we added the visual highlights to guide block selection. Here is the Ding Dong service architecture built on AWS Cloud with various frameworks, and it also has been successfully deployed to our actual test environment. We were selected for an educational donation program to test our service with elementary school students. We plan to implement the Ding Dong service and created the teaching material and conducted tests with lower grade students over the 4 sessions: initial assessment, 2 Ding Dong story recreation, and the final evaluation. Here are the actual block coding results created by the children. They easily used simple loops and conditional statements. Test results showed improved computational thinking skills, but limited class time suggests other factors may have contributed. Also, service feedback was positive, with about 90% interest in fairy tale creation and block coding. So we've wrapped up our project following the completion of the test. These are the sources we referenced. And thank you for listening to our presentation.